Good morning, everyone. Thank you for joining us. Today is February 7th. It is 11 a.m. Mountain Time. My name is Travis English. Appreciate you joining us for the Reliability in the West discussion series. This discussion series was our resource adequacy discussion series that we've been doing for the last several years, and we've updated the name and the scope of our discussion series so we can talk about more issues and things that are affecting reliability within the Western interconnection. So I appreciate you joining us for our first one of the year. As I said, I'm Travis English. I'm WEC Senior Training and Outreach Specialist. I'll review our antitrust quickly. All WEC meetings are conducted in accordance with the WEC antitrust policy and the NERC antitrust compliance guidelines. All participants must comply with policy and guidelines. This meeting is public. Confidential or proprietary information should not be discussed in the open session. This webinar is being recorded and it will be posted publicly. By participating, you give your consent for your name, voice, image, and likeness to be included in that recording. WEC strives to ensure the information presented today is accurate and reflects the views of WEC. However, all interpretations of the positions are subject to change. If you have questions, please contact our legal counsel. I'd like to take a quick look at some of our upcoming events that we'll be hosting at WEC this spring. The first one I'd like to spotlight is the February 27th to 28th Grid Fundamentals course that we'll be hosting. This is a 2-day course. It's 2 4-hour sessions, and it reviews technology, operation, markets, and just the power grid itself. It's meant to be a fundamental, so 101 of the power grid, but great for new people to industry. So if you could pass that along. And then our next one is the Reliability and Security Workshop that we're hosting here in Salt Lake City. This is March 26th through 27th here in Salt Lake City. So we're looking forward to that. The agenda has been posted, I think, within the last week here. So we have a link to more information that was provided in the chat for you there. And with that, we'll move on to our next event, which is our enforcement fundamentals. This is happening March 25th. This kind of coincides with that reliability and security workshop. It's the Monday before that kicks off. And this is our Enforcement's 101 training that we're hosting here in the WEC office. That's a full day training. It's a new in-person event that we're hosting. So more information on that in the chat as well. All right, with that, I'd like to jump into today's agenda. Again, appreciate you joining. Today, we'll be talking about inverter-based resources and ride-through capability, and emphasizing the importance of IBRs and their ability to withstand an event without compounding reliability issues. So excited to have panelists with us. We have Arif from Southern California Edison joining us. James Hansen, Manager of Operations here at WEC, Operations Analysis here at WEC. Ryan Quint, he's the founder and CEO of Elevate Energy Consulting. And then Victoria Ravenscroft, our Manager of External Affairs and Strategy here at WEC, will be moderating the panel for us. To kick things off, I'd like to introduce Ryan Quint. He'll be giving us a quick overview and fundamentals of IBR ride-through. Ryan?
Great, thanks, Travis. And let me see if I can share my screen here really quick. Fantastic, can you see that?
Yeah, good to go.
Excellent, awesome. Well, thank you for the invitation to be here. Excited to share. This is obviously a passion of mine. My name is Ryan Quint, the founder and CEO of recently stood up Elevate Energy Consulting, and really focused on trying to make sure we have a reliable energy transition here. And one of the most fundamental concepts, I think, is of that energy transition is ensuring that this new inverter-based fleet has some of the essential reliability services. So just want to give a really high-level overview for those that maybe aren't so familiar with this topic, which I think will be set a good groundwork for the panel discussion that we'll have thereafter. So for those that aren't familiar, NERC put out an essential reliability services document a handful of years ago, and it really focused on four fundamental concepts. Balancing, making sure we have sufficient resources to be able to manage and balance demand and generation. Frequency control, making sure we can control and have a stable grid frequency. Voltage, including dynamic reactive voltage, as well as steady state voltage control, and then to be able to manage these ramps that we're starting to see with variable energy resources. And so the concept of ERS is really centered around these four fundamental concepts, which were very relevant at the time. The world is changing very, very quickly, right? And so I like to sort of introduce this concept of essential reliability services 2.0, if you will, that includes a lot more concepts that are now sort of in the spotlight and getting a lot of attention because they're turning into meaningful reliability issues around the world, right? So these range across a spectrum of topics, which we could have whole panel sessions talking about each one of these. And I just put up some examples, right? This is not a comprehensive list. This is just my perusing of some of the main focus areas. So we have things like system damping, making sure a predominantly inverter-based system is stable and well damped, making sure we get sufficient fault current injection so our protective relays continue to work properly. Being able to handle and manage the decline of system strength, which is a term used to define how rigid and stiff that grid is, which has predominantly been provided by synchronous generation, which then leads into the use of grid forming technology for inverters, and then managing the increasing focus on dynamic stability, oscillations, controller interactions, and all of that stuff that we run into with a heavy fleet of inverter-based resources. But the one I really want to focus on here is that ride-through performance aspect. So let me try to define what that is, right? The ability of a generator or power plant to withstand a short-term disturbance and continue to reliably operate on the grid, right? So this is, in my opinion, the most fundamental component of grid reliability and stability. Having a strong continuity of generation is necessary for continuity of serving end use load and customers, right? Without generation, there's no power to deliver to customers, right? So minimizing the disruptions of the electricity supply results in a better delivery of power to end use customers, right? And we leverage performance standards and requirements that mandate certain levels of ride-through capability of generators, and those types of requirements exist all over the world. So what do we mean by short-term grid disturbances, right? You use your imagination. I'm sure we could come up with a list of 1,000 different examples. I love that our industry is the only industry where you say a squirrel climbed on the bus, and it means something wildly different than if you asked my 2-year-old. But things like lightning strikes, equipment failures, animals, wildfires, smoke has caused a number of grid disturbances. Natural disasters, hurricanes, tornadoes, storms, floods, etc., tree contact, which we have standards for, and then cyber and physical attacks, right? And I like to show that this is a statistic from, I believe, 2022. There are 28 million, almost 28 million lightning strikes in Texas alone in 1 year, right? Not all of those are ground contact. A lot of those are cloud to cloud. But still, like, to put that into perspective, grid planners will often say, grid faults are common, and folks that aren't familiar in this area sort of say they shouldn't be. Why are they, right? It's for these types of reasons, right? These natural events that affect the power system, and we plan and design a grid to be able to withstand certain types of these short-term grid disturbances through the requirements that we put forward. So to explain how this kind of interacts with stability, right, that frequency stability that are referred to, which is an essential reliability service, is that balance of generation and demand, right? And so as the 60 hertz that you see out of your wall outlet over there in the corner, right? That is the balance, the continual balance of generation and demand. And as we get more demand relative to generation, frequency starts to drop. The motors have to work harder, right? And so frequency will start to fall. And so we plan a system that's able to withstand a certain amount of generation loss, tripping of a large power plant, for example, in the West, a couple nuclear plants, for example, a couple nuclear units, right? But we don't plan the system for the loss of that generation, in addition to an unknown amount of generation resources unexpectedly tripping off, right? So like I mentioned, as demand starts to exceed generation, the scale starts to tip, and we have thresholds out there on the system where we have under frequency load shedding. So if frequency falls to a certain sort of unacceptable level, we will trip load to prevent that evil three from happening: widespread instability, uncontrolled separation, and cascading, where the system has sort of gone too far and cannot recover, right? So there's this balance of generation and load, and the ride-through aspect comes in because we need to make sure we can understand how much generation we could potentially lose, right? So NERC, working with WEC and Texas RE and affected entities, have written over a dozen large-scale, widespread resource loss disturbance reports over the last 7 years or so, going all the way back to the Blue Cut fire in 2016, and then more recently with some battery energy storage events that happened in 2022. We've had the infamous Odessa events in Texas that were relatively extremely large resource loss events that almost hit that maximum amount of generation loss that the system can withstand. And out of those reports came, I won't read all the text here, but they came very strong recommendations from the Euro Enterprise to significantly enhance the ride-through standards, i.e. PRC 24, with a more performance-based comprehensive ride-through standard. PRC 24 has a long history, but ultimately resulted in a standard that is focused solely on voltage protection and frequency protection, and that's it, right? And that is, 1/100th of what a plant relies on to reliably ride through grid disturbances, right? So these IBR facilities have introduced new challenges where we're tripping on PLL loss of synchronism and reverse current flows and turbine failures, power, uninterruptible power supply failures, phase jump protection settings, overcurrent protection, right? So all of these different forms of protection are now tripping these facilities, or have tripped these facilities in the reports that have been written. And we now need to sort of revamp our requirements to make sure that we capture the same essence of what we were shooting for, 10 plus years ago when the system was predominantly synchronous generator based. So to give a little teaser, I think, to some of the discussion that we'll have, right? I like to lay out this sort of process flowchart, if you will, and I like to work from the right-hand side backwards, right? So why are these things happening in real-time operations, right? That's the ultimate question. Why is this happening? We have to work our way backwards and ask, well, how was the facility commissioned at the time of commissioning? What was installed and why? What studies were done to make sure this resource can reliably ride through these events? Were the models used to run those studies adequate and sufficient and accurate and adequately represent the controls and settings within that facility? And are there fundamentally even requirements that exist that say this facility must ride through this event? And the answer to that has historically been no, except in a couple areas, right? So we have to kind of shore up gaps, notable gaps in this whole process if we expect the reliable operation of these IBR facilities will ride through these grid events, right? And the one thing I like to highlight, just to kind of close it out, is that we're all on the same team here, right? The generation facility, the development, or the generation community and the development community, they want, right, a reliable fleet of clean energy, inverter-based resources, providing these essential reliability services. The transmission service providers, the transmission planners, the system operators, they rely on these facilities to provide those essential reliability services. And like I said, we rely on equipment standards, things like IEEE standards, IEC standards, as well as performance-based NERC reliability standards and regional standards to ensure that we have that reliable operational performance in real time. Addressing this ride-through performance issue, in my opinion, is step 0 of this clean energy transition, and the Euro Enterprise has been highlighting for years that we really need to get this right like yesterday, because we have a lot more vastly more difficult challenges ahead of us in terms of managing a future grid that is predominantly inverter based, right? Things like energy adequacy, wildly changing grid stability margins, a drop in system strength, and how we plan to manage that with new forms of controllers, new grid forming inverters, etc. We're seeing an increase in oscillation, a decrease in system damping. We've got notable controller interactions, plants doing erroneous things after they've been commissioned, a decline in system inertia and the need for fast frequency response, and a whole new environment of protective relaying, fault current injection, etc. Those are very challenging things that we all have to face, and very smart engineers around the whole world are tackling those things, but they're doing so with the expectation that the resources are riding through basic grid disturbances. And so the Euro Enterprise has been continuing to highlight, hey, we can't forget about the absolute fundamentals before we try to jump to this fun R&D activity of running 100% renewable based grid, right? We've got to focus on those fundamentals, get that right so we can move forward. So I'll leave it at that and look forward to the conversation.
Great, Ryan, appreciate you walking us through the basics and the fundamentals there. I want to bring in Victoria Ravenscroft. Again, she's the Manager of External Affairs and Strategy here at WEC, to get into the conversation. We did get a question that came into the chat, but I think we're going to address it in the panel that we're about to jump into here. But I'd like to encourage participants to continue putting those questions into the chat or use the raise your hand feature, and Victoria will address them as we walk through today's discussion. So with that, Victoria, I'll turn it over to you.
Great, thank you, Travis, and thank you, Ryan, for that great overview. You know, when we picked the topics here, IBRs immediately sprang to the top of our list for 2024, and this is the first of a couple or few conversations we're going to have, and I think Ride Through is a great place to start. So I really appreciate the overview that you just gave on that, Ryan. So where we're going to take this today is we're going to take our panel down the path of talking a little bit about where we've been, particularly with regard to the lessons that we've learned from these different events. Those, I think there were 10 different events that you showed on your slide there, Ryan, and curious about where we've been and what we've actually learned and applied from those events. Talk a little bit about what's the status now, and then moving on to, you know, where are we going forward? What's the future looking like going forward? Okay, Travis, can you still hear me? I had a change in my screen and I just want to make sure I'm still connected.
Yep, loud and clear.
Excellent. Okay. So to start with, I want to start with James Hansen, who has done a lot of work with events here at WEC. It's been in his bailiwick for quite some time. To talk us through where the West is right now with regard to the lessons learned, starting with the Blue Cut Fire and through those various events. What have we done? What have we improved in the West based on some of the lessons we've learned from those events?
Sure. I guess I'm going to start off, you know, with Blue Cut, and one of the most important things that came from those disturbances, and it was actually, there were 15 different outages that took place August 16th, 2016, when that fire was burning through that transmission corridor, was awareness of the implications of having such a penetration of IBRs on the system. And what happened shortly after the Blue Cut Fire events, there was a meeting in WEC offices in Salt Lake. And this was one of the first meetings, at least that I had attended, where we had industry representatives, we had NERC representatives, we had regional entities, we had inverter manufacturers at the table, and we had plant owners. And we were sitting around, and as kind of an introduction to what happened on August 16th, there was a mention that we cannot have these inverters trip off during normally cleared faults. And let me explain normally cleared faults for a second. These faults were being detected by relays in substations tens of miles away. Those relays are sending signals to circuit breakers, and those circuit breakers are opening up that fast. It's happening in 40 to 60 milliseconds, and yet these inverters were not riding through a disturbance that was on and off the system that quick. So the statement was made, we can't have these inverters trip during these type of events. And immediately an inverter manufacturer raised his hand and said, most of these inverters did not trip. They momentarily ceased to inject current onto the system. And that was one of the first times many of us that have power system background heard the concept of momentary cessation, because it sounded like tripping a lot to us as we looked at things. So it became very clear that inverter manufacturers and power system experts were not on the same page in that meeting. Happened very quick. Very shortly after that, in that same meeting, we said, why did these inverters act the way that they did? Well, we took standards, both IEEE standards, and we took NERC standards, and we applied them. Well, as we got talking about them a little bit more, they both, IEEE and NERC standards, were being misapplied to them. There was no communication amongst relevant parties up until that point. So when I say awareness, the best thing that came out of Blue Cut Fire, in my opinion, was awareness and improved communication between inverter manufacturers, generator owners and operators, regulators. We weren't talking together. We were assuming, and with the best intentions, doing the best we could, but there were so many things that were wrong. So during this meeting, we caught a small glimpse of the vast amount of work that was before us. And that vast amount of work touched on performance improvement, ride-through capabilities of these inverters, existing standards at the reliability level and also performance level, IEEE. Another key thing that came out of this meeting and this initial meeting that happened in WEC offices was it really kicked off the creation of the inverter-based task force under the NERC committee structure. And that committee is now a subcommittee. That group is now a subcommittee. But that provides an opportunity for all of those relevant parties to come together and to address challenges, to talk through standards, whether we can adjust an existing standard or if a creation of a new standard is necessary. So many key things happened after Blue Cut that really has turned into a vast amount of work over the last several years. And we are still in the thick. Like Ryan says, step 0. Unfortunately, man, we're still in step 0. And we see multiple steps moving forward that need to be addressed. But man, we've got to get step 0 down, and that is the performance of these resources that we are becoming more and more dependent on as we're seeing more of that traditional generation get retired and more of these power electronics based resources coming on. So I would say communication and awareness are some of the greatest things that happened from that initial Blue Cut, but also that has created such an opportunity for working together to address these issues. And ideally, that would have been done earlier. Than we wouldn't have had to rely on an event to get us there. Mm-hmm. But sometimes it does take an event to open our eyes and say, we're we're in the midst of something big, and that's what happened. So.
Well, I appreciate that. It sounds like this, the awareness is there, and based on Ryan's slides, we are learning and growing and sharing that knowledge, and I think that there's a very robust culture within the industry to share the knowledge from these types of events. But I can't help but wonder, from the perspective of our audience, Blue Cut was now almost 8 years ago, and we've had events since. And so I want to open this question up to all three of our panelists. What have we done? I know we've learned a lot. We've learned a lot about this. I think it opened our eyes, as you've mentioned. What's been done to the fleet in that time, and particularly to these legacy inverters on the fleet? Are they being updated? Has this been changed? Where are we today with regard to the legacy fleet? And maybe the corollary question to that is, has this been addressed in the new elements that we're putting on the system today?
I've talked a lot already, so I'm happy to jump in, but if somebody else would like to take a first stab.
Maybe I'll jump in, James, if I can,
Sure.
and we can bounce off each other here. But this is so I guess I'll caveat this by saying there's a lot of tremendously good work going on. There's a significant amount of inverter-based resources being added to the system every single day. A significant amount of that is probably being interconnected very reliably, right? So I have to give that caveat, right? That this is not this is sort of an alarmist discussion, but at the same time, there's a lot of great work being done. So that needs to be acknowledged. The problem is that it doesn't take a lot, frankly, for a bad day to happen, right? A large handful of sort of bad actors or facilities with bad settings can result in these very serious near miss events, right? The Odessa events were very close to exceeding that largest credible contingency, right? Which is a very scary situation to be in for, like James said, a normally cleared fault that should really have not tripped anything, right? So we have to kind of also understand the gravity of the risk, right? So two things I would highlight are the recently published NERC alert report, which did a pretty comprehensive assessment of what's out there on the system. NERC issued a level 2 alert, which required mandatory reporting from all solar facilities to really understand the extent and condition of some of those risks. And the findings of that report mirror the findings of the Southwest Utah disturbance report, which was an event that happened last year. I was the primary investigator of that, along with James and some other colleagues at WEC. And that report is frankly a little jarring, right? Because what it says is we've had facilities out there for 7+ years. They were very much aware of the guidelines and the recommendations that had been put out by the ERO enterprise. And the answer essentially was that they did nothing, right? So got to kind of let that set in, right? That they were aware of the guidelines, they were aware of the best practices, and there was no implementation. Now, there's various reasons for that. It costs money, it's complex, you have to work with the equipment manufacturer. Sometimes the generator owner's hands are tied in that regard to do that. Maybe some of those OEMs don't no longer serve that vintage of inverter, etc. But that is the current situation out there, right? That a lot of legacy facilities still have some of these systemic risks associated with them, which comes back to the recommendations that are in much of the NERC and some of the WEC, joint reports that have been put out regarding, we need to sort of raise that minimum bar, right? So like I said, many entities are probably operating up here in terms of their, operational excellence, but the bar has been kind of lower than the screen can show, right? We've got to raise that bar up to a level that will ensure an adequate level of reliability. And in the past, that bar has not been there, right? There was not a requirement that said thou shalt ride through, right? So resources are technically, right, essentially meeting meeting compliance with PRC 24, yet still tripping for every single event, right? That's a gap, right? That's a reliability gap that needs to be shored up and should be shored up on short order, right? And it essentially took FERC Order 901, took FERC mandating it for it to really get kicked into high gear, right? So now we're seeing some significant progress in that area. The other thing I'd highlight is that I think is really important is that each event is sort of uniquely different. There's a lot of similarities, but each one's different, right? So that high level question of why did these things keep happening, right? That's a good question for somebody, like an executive. I had that question asked to me numerous times. Why is this still happening? And part of the answer is we're learning new things every time, right? So Blue Cut was a frequency problem. Canyon 2 fire was an over voltage problem. The battery events were a completely different problem. They're similar, yet uniquely different. They often involve different manufacturers who are doing things slightly different in their controllers, right? So there are a lot of underlying success stories. Some of the inverter manufacturers have gone back. Blue Cut is a really, really good example, right? Without naming any specific names, there was really one manufacturer that was at fault for most of the Blue Cut fire tripping. They went back and fixed their entire fleet essentially before we could release the report. They did it that fast. They sent techs out there to the whole fleet to change out their settings, right? That's a huge success story that kind of shows what we can do. There are other not so good success stories of OEMs that have said we have a fix and we're not rolling it out unless asked, right? Which is why the Aero Enterprise has issued some of these alerts to sort of make sure that the asset owners know, hey, you've got a fix, you need to go ask for it. So we still have some gaps there, right? I think to really have significant confidence that these events are disappearing. And what we see is that the frequency and the magnitude of these events is actually increasing, not decreasing, right? So we can sort of trend this over time. And we did have a lull. I think it was in like 2019 or something, where I think we had 1 year where we didn't have any events, and we thought, gosh, we fixed this, right? That was a false sense of comfort, I guess. And then following that, we had 5 or 6 large disturbances immediately after. So I think we do have some serious work to do still, again, to just kind of raise that minimum bar and make sure everyone's meeting that minimum bar, and fully utilizing the capabilities of modern inverters is another really important point. So I'll leave it at that.
Well, I want to underscore a couple things that both you and James have kind of mentioned. And the first is that there is work happening. And I think for folks that don't swim around in this every day, it's easy to look at the number of events that have happened and the increasing frequency and magnitude of the events and go, uh-oh, we're not solving the problem. And I'm appreciating what I'm hearing is that we're solving the problem. We're solving it. There are good actors out there, and we've gotten a few questions from folks and comments saying, hey, we should be highlighting the good actors, and I think it's worth noting that people are doing things, to your point. Something else strikes me in what you're saying too is that this is an incredibly complex problem that is materializing at a rate we've never probably seen on the system before. And so I just want to underscore that point that you made, that there are different causes in each of these events. And so it's not that the same cause is coming up over and over again and we're just not solving the problem, that there are some different causes in this very complex issue. One of,
Yeah,
in all of, oh,
yeah, this is Terry from Edison. Maybe
oh,
I
good.
can
I was just
add.
going to see if you were back with us. Good. Arif, I'm
Yeah,
going to turn to you.
I
I'd like
think
to hear what you have to say about it. Yeah.
I think can you hear me? Can you
Yep.
hear me? Okay.
Can hear you just fine.
Okay. I think it's something to do with our internal IT thing, because we normally use Team, not the WebEx. So whenever I put it in the internet network, it kind of gets slow. Anyway, so that's a very good question in terms of what people are doing. The reason I'm saying it, actually in 2019, 18, that kind of things we thought about at SCE. In other words, you have a feeder and now you're putting like new smart inverter, where the legacy can only perform like 2 functions, where the smart inverter can do 8 functions, right? How that gonna interact with each other, and what kind of issues that you're gonna face in terms of like harmonics injection, in terms of like production setting. So actually, we started the project in 2019, and we recently completed a project where we kind of simulated and did a lab implementation in terms of what will happen if you have different kind of inverter combination into one feeder, what kind of issues that you're going to face, what kind of things that you can expect. And it turned out there are some right-through issues there. In other words, maybe it will not be meeting your smart inverter is not going to meet 100% what you expect out of this technical sheet. So depending on the feeder nature, depending on the situation, depending on the what kind of phenomena that kind of exist in that feeder, things can change. So what we did, we kind of, once we are done with that project, we kind of put down, summarize everything and put it in a public document in terms of like the output and input, what was the consideration, what are the research questions that we answered throughout this project. So I would encourage our attendees, like to go in, and it should be under EPIC by CPUC. So that's the public document. You can go in, and we always put our final kind of report or final findings into there. But that's yes, that's a very good question in terms of what's going to happen. And just to assure you, yes, we within SCE and as well as like other IOs, we also work together. We always inform each other, but we all are stakeholders to each other, right? So whatever we do, it kind of flows down to the other two utilities that you see in California. So yeah, someone somewhere is working on it. I can assure you that.
Well, and you were at the nexus, right, where sort of the idiom rubber hits the road there in the utility. A question for you to kind of to bring in the conversation about vendors. And Ryan just mentioned that before the report for the Blue Cut was even released, that particular vendor had already, sent the word out and it made changes. And we have other vendors that aren't making changes. Can you talk a little bit about how you all work with the vendors in your situation and how that's been over the last, 7 to 8 years working with the vendors and your experience and getting their help and partnership in fixing some of the ride-through issues?
Yeah, so basically, I think like from our point of view, we try to address this issue into three fronts. One is we have our internal stakeholders. Internal stakeholders mean the one that really put down the gist of it. Like we have to work backward. We have to look into the what kind of phenomena that we are seeing in the field. That goes back to your commissioning phase, that goes back to your dynamic modulation and modeling, and that goes back to an interconnection requirement. So we kind of look into, we kind of a constant contact with our field engineering, see what kind of issues that they are having, put it down into some sorts of like, we kind of make a projects around that issue, and we kind of flows down whatever the findings that we think is definitely needed for our interaction requirement, we kind of update that one. So that's like one way we kind of tackle this. The other way we really tackle this is kind of we partnership with other universities, we partnership with other DOE labs, and then kind of build a high fidelity model. We recently completed one project where we partnered with a couple of other folks from university, from DOE National Lab, from ABB, and then kind of we put down a high fidelity model. We kind of replicated exactly, our model was able to replicate exactly the issue that happened in Kansas Forest. So that's the disturbance we kind of model. So those are like high fidelity model that we have developed, and that's another way we kind of address the issue. The third way that we address the issue, and that brings up your point, like how we interact with the vendor or manufacturer or other folks. So the output of this goes through the standard committee that kind of forms. For example, IEEE 1547, we always put our input there. There are a small inverter working group. There are like other inverters, Rule 21 working groups. So we always get involved with this, and we always keep giving them the findings that we are having in the lab or in the field demonstration. That's how we kind of blend with the inverter manufacturers and the vendor or aggregators, and then kind of so that we all can, as Brian said, like, it has to be a team mentality, right? I mean, when someone wins, everyone kind of wins, and that's the kind of same kind of situation. So that's how we kind of blend with them, and we always keep in contact with them. We update the CPUC just to make sure everyone knows like what's happening into the utility phase.
Okay. And before I turn to a question from one of our listeners here, Ryan or James, any thoughts from your perspectives on sort of this same team? And I love that concept. I'm glad you put it on the slide, Ryan. But what's the experience been like with the vendors coming to the table recently on this issue?
in my opinion, I think it's a mixed bag. I mean, we've got examples of vendors that, man, we identify an issue and their name's attached with that inverter. They're going out and they're fixing that. And then we've got other frustrating situations where we identify a performance issue and that inverter's manufacturer will say, we'll implement a fix when the plant comes to us. And there's no proactivity about it. They're just waiting on, we'll address it, we'll fix it when they come to us. And we've encouraged a different approach. And they said, no, this is what we feel comfortable with. I think we're definitely in a better situation right now than we were years back. Inverter manufacturers have a better idea of what we are expecting to see when putting together a utility scale solar plant. Setting improvements, the working together. And that's really what it is. I mean, a lot of these issues came about from really smart people working alone, groups working alone. And now that we have kind of created a community where we're addressing these issues together, like Arif just said, we're all winning in that situation. We can all feel good about solutions, and having the right people in the room when those decisions are made is really moving things forward in a better manner. So that's kind of my thoughts.
Great, thank you, James. Ryan, any thoughts on the vendor issue?
Yeah, and I think there's an underlying, important message that sort of needs to be pulled out, is often not talked about, right? That the solar community grew up in the distribution world, right? So that's where momentary cessation came from, and all the utility, bulk system utility folks said, "What in the world is this thing? Like, we never heard of this. What is this?" It was a thing that had been used pretty predominantly in the distribution world, and then sort of propagated itself up into the bulk power system using the same type of product, right? The same product that was being built for rooftop systems, then sort of ended up on the bulk power system. We've come a long way. We've addressed many of those problems. In short order, we collectively as an industry sort of said, we've run studies. We've showed that this is going to cause a widespread outage, and we need to stop this thing, right? So we've done everything we can to get rid of this momentary cessation problem. And now on a tripping type of ride-through performance issue, there's a fundamental point that the product that is created and manufactured is built to a spec, and that spec is based on equipment standards, right? And so each of these products are competitive around the whole world, right? And so they build their products to meet the German grid code and the Australian grid code and the UK grid code, and et cetera, right? And then what they do is they build out and this is not, generalized across every single manufacturer out there, but it's pretty common that we hear that we build a US product and we turn all those bells and whistles off to meet the minimum specification necessary for that grid code, right? Because there's a liability risk if I do more and I start acting funky, right? I could not be in compliance with the grid code, right? So they're built to spec, and whatever those specs exist is what they're built to. And historically, there has been no spec, right? And so when we had some of these first disturbances, and we were working very closely with all of the manufacturers, a lot of them, we were kind of shocked to hear they're saying, well, so you just give us a requirement, because right now we're setting things sort of unknown on what you want, so please tell us, right? So that led to the NERC guidelines, that then led to IEEE 2800, which is now adopted, and industry is now focusing on this .2 performance conformity and verification, sort of how to put that into effect standard, right? So focus is now really specifically on leveraging, implementing, and adopting IEEE 2800, which really raised the bar from essentially nothing to something quite high, right? But now we've got to go and adopt it, right? NERC has, sort of come out and said we are not enforcing 2800. FERC has also come out in Order 901 in 2023 and said we're not enforcing 2800 because it's IEEE standards and there's complications and legalities with pointing to an IEEE standard that's not owned by the Euro enterprise and the federal government, right? So where we are is the utility industry now has to sort of grapple with each transmission service provider, transmission owner, system operator, et cetera, needs to adopt 2800, and that's on everybody's radar. So a lot of work is now going into how do we effectively adopt this standard and then enforce it. And so that's going to really raise the bar. And that's where the OEMs, the manufacturers, they come out of the woodwork to to lean in and engage on those equipment-based standards, because that's where the product has to be built to spec, right? So I've been engaged in international IEC standards over the years and was engaged in 2800 and now kind of monitoring .2, and you've got every manufacturer at the table there because they are keenly focused on what is that going to do to the way that I manufacture my product, and how do I prove that when I'm doing that, right? So that's a good thing, right? We've now got a lot of attention on the standardization and improvement of performance for the inverter-based fleet. My stress here is that we need to make sure that we are putting that standard into effect, because all IEEE standards are voluntary by nature, right? They're not mandatory and enforceable like an NERC standard, like a FERC directive. Those IEEE standards need to be adopted and enforced, just like 1547 needed to be adopted and enforced by the authority governing interconnection requirements, the state PUC, whatever, right? So that's where almost all the focus is right now, which is a good thing. It's going to take time for that to propagate out into the system. And so we're kind of in a bridge mode of making sure we don't have any large scale events until we've got a really robust fleet that all conforms to IEEE 2800.
That's helpful, and it brings me to the question, sort of to turn this conversation to the future. What, hearing the 2800 issue and sort of the complexity there, but are there other risks that you see going forward that you would put in your top 3 with regard to the ride-through issue on IBRs that need to be addressed immediately? Are there other areas, Ryan, you, Arif, or James, that we just need to be doing more quickly on?
Modeling.
Yeah, I totally agree with that modeling. From the utilities point of view, they are kind of, we have that set of mentality where we don't take a high fidelity model. We kind of take it as a lump sum load and kind of do the inverter-based resources as a single load. That mentality, there are so many things, so many functions that you can apply with the inverter, and modeling can be done in a detail with the dynamic part of it. And I think that's one of the key challenges that at least I have seen in my experience with the utilities. It's hard to get people on board on saying, okay, this is the inverter, it can do so much for you, so you should focus more modeling effort or put a lot of dynamics what the inverter can do and kind of go from there. So I totally agree with James. I think modeling is my top 1 priority for that.
So modeling it, and I would imagine, having heard that both from Arif and James, that we're talking modeling across the spectrum, right? From the high fidelity models that you're referring to, Arif, at the utility level, all the way up to perhaps interconnection wide models, or at least regional models on how inverter-based resources can affect the system in a macro kind of a way.
We've got to be able to know how these resources are going to respond when there's a fault on the system, or our real-time system operators are really flying blind. So, I mean, if we can't accurately represent that, are we operating in a known state? And that's a scary situation. to know that we have all of this penetration that is growing on a daily basis. And do we really know how they're going to perform when there's a fault nearby? Are they going to be able to ride through it and continue to provide provide support for that fault? Or are they going to go away? And what's going to happen when we get a huge penetration, a huge population of these inverters going away? We know what's going to happen. It's going to throw off that balance between generation and load that Ryan said. And that starts leading into instability and putting our system operators, our real-time system operators, in a situation where they're not able to have confidence in their models. That is not where we want to be. So
I appreciate that response. I want to ask one audience question because it has to do with data and information sharing before I kind of close out with our final question. You guys have been really good at answering all the questions before I can get them asked, but this one here is kind of hanging out there. And it references the NERC2 alert and the findings from that for IBRs and this gap between geos and inverter OEMs, so the manufacturers there. And getting data, and geos are saying that they're having difficulties getting data from OEMs. And some of the OEMs have even indicated that they don't have some of the data that's being requested from the level 2 NERC alert. So the question here is there an effort, and I would say what kinds of efforts are going on with the ERO, so NERC, WEC, and the other regions, in reaching out to the OEMs to educate those entities on what's required by NERC, what kind of information some of our generation owners need, and the information that's generally needed from the OEMs to start or continue chipping away at this problem. What kind of efforts are underway in that realm?
I can jump in. James can talk to the efforts underway at the ERO enterprise level.
Yeah.
I can
Yeah.
sort of no longer speak to that, but the underlying story there with the alert was that we issued that alert. I say we because at the time I was at NERC and it was my team issuing the alert with the assumption that everything that was being requested was sort of necessary to demonstrate compliance with various standards. Right? What's your reactive capability? What are your protection settings for PRC24, et cetera, et cetera? And if you look in the report, it showed that we had frightening response rate like the day before the alert closed, right? Usually, historically, that percentage was like 95+%, and I think it was like 6, right? So we had to issue a one-time extension because we were getting so much backlash from that community, the generator owner and OEM community, saying, you've asked for things we don't have, which was shocking because we looked at it thinking, I would assume you would have your reactive capability per VAR1 and VAR2 standards, right? Like, it's not that hard. Like, I don't want to say not that hard, but should be readily available, right? So, we were getting calls from the generator owners saying, we don't have this data. What do you want us to do? And then we're getting calls from the OEM saying, do you realize how much work you've piled on us by this request, right? Which highlights a fundamental single point of failure, if you will, that to get meaningful information about how your facility is going to behave, there's probably one person per organization in the United States that can get that data for you, right? And that one person gets piled on all of the fleet for the alert data, or a couple people within that organization, right? They're responsible for going out to or remoting into every facility to get that information, et cetera, right? So that's a shift, right? That problem doesn't exist in the synchronous generation world. The synchronous generator owners know what's in their facility. They've got a team of 50, 60 people working on that facility 100% of the time, right? Many of these IBR facilities have no one on site. They're remotely controlled, and a lot of times they don't know what's inside the inverter, inside the PPC, and so their hands are tied, right? As now I've left NERC, I'm now realizing through these discussions, more intimate discussions with the industry, that the generator owners feeling really their hands are tied with the contracts that they signed with the OEMs, right? So there's some meaningful effort that needs to be had regarding strengthening these relationships with the OEMs to make sure that that data is more readily available when these types of issues, arise.
So it sounds like it's almost more of an availability of the data, less so an awareness of the type of data that's needed. Maybe just getting the data is what's problematic in a lot of cases.
I think so. Yeah,
Okay.
from what I hear.
So looking at our time, there's one question I really want to get to because a lot of our audience are decision makers of some sort, whether that is state commissions. We have a lot of state utility commissioners in our audience, as well as other types of decision makers. And I don't want to miss the opportunity to give each of our panelists, it looks like just 1 minute, to say what you want, what you think needs to be shared with decision makers, whether that's what they can do or what they need to know about. A lot of these folks have something to do with the process of resource planning. So if you had a minute, which you do, to sort of give your message to decision makers in the Western interconnection, what would that be? And I'll let any you jump in.
I can go. I can go first. So
Please.
I think one of the messages that I want to say to the decision makers is more of a encourage the vendor or the manufacturers to not to give a black box model of their system to the utility. Instead, give them a like kind of really dynamic models that we can play with so that we can replicate the event internally and change some of the parameters here and there just to adapt that system with that kind of incident, and then kind of we can have those sorts of feedback we can give it to the manufacturers so that they can build their model in a more proper way. So yeah, encourage them to work with us so that we can have a fruitful things for them.
Great, thank you. Great.
Thank you.
James or Ryan, what would you say in your time here with decision makers?
I would say, please weigh out the challenges that industry is facing right now in this transition. We are in the midst of one of the fastest energy transitions that this industry, probably the fastest energy transition this industry has ever faced. And it is significantly different as we're looking at synchronous generation to this inverter-based generation. We have some very aggressive, some states have very aggressive clean energy laws. And, you know, we are working on these challenges. There are people that's what we do. But these changes take time, and we understand that there is these resources, they play a major part of power systems of the future. But we need to make sure that we have these right before just adding more and more and more. And if we don't have the right models, if we don't have the right settings in place, we are exacerbating the potential problem of these. We need we need some time to make sure we've got this right. So that's my thought.
Great, thank you. James. Ryan, I think we'll close with you and what you would say to decision makers at this point in time.
Yeah, it's a great question. I think it goes back to that same team mentality, right? I think let's end on a positive note. But what I think is important in the context of that same team mentality is that we need clear, effective, just, reasonable requirements on this new fleet, right? Everything stems from sort of the lack of requirements, the lack of clarity of requirements, etc. So while we can say we want better models, if you don't have a requirement dictating the quality of that model, you're not going to get it, right? So we have to improve the requirements, which will make the generator owner's life easier, the developer's life easier, the equipment manufacturer's life easier. That will lead to a faster interconnection process, a cleanup of the queue, along with everything else going on. But this significant revamping of requirements, I think, is really necessary. That doesn't mean more requirements. It doesn't mean stricter requirements. It doesn't mean unfair requirements. It means getting clear, consistent, just, reasonable requirements. Everything sort of plays out after that if you have those requirements in place in terms of model quality, study quality, commissioning practices, and then real-time operations, right? So that's my 2 cents, is that bolstering of requirements needs to be understood by the state regulators when the utilities are coming to them for those changes. It needs to happen at the FERC interconnection agreements and procedures level. We're seeing it across the board in the NERC reliability standards. We just need to make sure those standards are reasonable, fair, just, et cetera.
Okay, thank you for that. And I love ending it on the same team. And I would only add this, that there are multiple roles to be played by multiple, different diverse parties, and we can all play our role. So with that, thank you to the panel. I'm very quickly, we're here at the top of the hour. I'm going to turn it back over to Travis to close us out. But thank you, Ryan, Arif, James, for your contributions today. Great discussion. Travis, I'll turn it back over to you.
Yeah, thanks, Victoria. And I'll echo that gratitude. James, Ryan, Arif, appreciate you joining and sharing with us this morning. I know there were a lot of questions we didn't get to in the chat, but as Victoria mentioned earlier, our Reliability in the West series will be covering IBRs in the next couple of sessions. So we'll keep you posted on that. Mark your calendar, March 6th at 11 a.m. We'll be talking more about this topic. So appreciate everyone joining us and look forward to our next discussion. Thanks again, everyone.